We have here a figure showing the four main components of the computer system: the input device, the output device, the main memory, or also called the RAM, random access memory, the built-in memory of the computer, and the fourth is the CPU. This figure tells us how each component relates to other components. The arrows here tell the flow of data from one component to another component. Like in the case of the input device, we have here two arrows pointing from the input device to the CPU and another arrow pointing from the input device to the main memory. So since the arrow is in that direction, it simply means that data coming from the input device, whether from the keyboard input or mouse, it goes to the CPU for processing. And another instance also would be when the data are sent to the main memory for storage. So when the data is sent to the CPU, that is for processing, to be used for the program's computations. And when it is directed to the RAM or the main memory, that data is to be stored in the memory locations. Computed data from the CPU could be sent to the output device for printing if it is the printer, or for display if this is the monitor. Another possibility is that data coming from the main memory, stored in the main memory, will be transmitted to the output device, maybe monitor for display or printer for printing. And the last remaining one, which is this, take note that it is bidirectional. The arrow line is directed from the main memory to the CPU, and on the other end, the arrow line is directed from the CPU to the main memory. We call this a bidirectional arrow line, since it has two directions. Bi means two. Data can flow from the main memory to the CPU, or it could also flow from the CPU going to the main memory. When, say for example, the CPU is trying to execute the instruction z gets x plus y, and say variable x storage or memory location is this one, say for example this is 4, and y is maybe this one, and say for example this is 3. So say this is the memory location allocated for variable x whose value is 4, and say this is the memory location allocated for variable y with the value 3. Then when the CPU is executing this instruction, that is to get the sum of these two values x and y, the CPU needs to fetch the values of x and y from the main memory. So x, which is equal to 4, will be sent or transmitted to the CPU, and y equal to 3 will be sent also to the CPU. So that when this has a value now, 4 and 3, and then z will become 7. And this value, 7, will be sent or transmitted back to the main memory. Say for example, this is the memory location allocated for z, and therefore this value 7 will be transmitted or will be sent to the main memory at the location of z. So we'll have here 7. That's the reason why this arrow line here is bidirectional, because data could flow from the main memory to the CPU, and data could flow from the CPU back to the main memory for data storage.